Hello and welcome back to my YouTube channel. Today we are going to be building a RAG chatbot and we'll be talking about what that means in a bit. RAG is an acronym for Retrieval Augmented Generation. So there's going to be Generative AI, there's going to be retrieved information, there's going to be augmentation. So the Generative AI will use the retrieved information to augment the answers that they will be given to the users of this chatbot. So let's take a little step back and I'll try to explain this thing as simply as I can. Imagine that a fitness company hires me to work at their gym and I am a service desk assistant. I'm supposed to answer the customers' questions about the gym and give them instructions on the next steps they're supposed to take. So before the company hired me, I as a person, I have some skills, I have some abilities that I came with. I have knowledge of world events. I'm able to have meaningful conversations. And all this is based on what I have learned while growing up as a child and even into adulthood. I have my own personal knowledge base based on what I have experienced. In this case, what I've been trained on. Now, this fitness company, if they just hire me and put me at their front desk, I would not be very helpful to them because I do not know anything about the gym. Now it's their responsibility to onboard me, give me a training on what the company does, the kind of services that they offer, what times of the day that they open, how many times a day that they open, the kind of classes they offer, so that when a customer asks such questions, I will be able to help them. Okay, now back to Retrieval Augmented Generation. I am a generative AI. I'm able to have a reasonable conversation. I'm able to come up with answers to people's questions. I'm able to talk to people. Now, when a customer asks me a question, I have to go to the knowledge base that I have about the gym and retrieve the relevant information about what the user is asking. And I'm able to augment my generative skills with the information I retrieved, and then I'm able to answer the user's query. So that is Retrieval Augmented Generation. Generation that is backed up with retrieved information, specific information about a certain use case. This document is a sample of a knowledge base, in this case for the fitness company, and it contains all the information that we need to be able to answer the user's questions. So how does this RAG chatbot work? The first thing it does is to find relevant passages or paragraphs or sentences from the knowledge base based on the user's question, and that is the retrieval part. Then it uses the retrieved passages and conversation history to generate a comprehensive answer. And what does the conversation history have to do here? So back to me as an example. So a customer walks up to me and says, "Hello, my name is Jennifer. I would like to get some information. I would like to make inquiries about the gym." If I don't take note of the customer's name, then I'm probably not doing my job well. So I have to take note of the customer's name, store it in my memory so that I'll be able to relate in a friendly manner with this customer. So the customer and I are having this conversation back and forth. And at the end of the conversation, I say something like, "Thank you so much, Jennifer, for stopping by. We hope that you register with us as soon as possible." Now, if I did not take note of the name of the customer, I wouldn't have been able to say that. So this is not just about answering their questions based on the knowledge base I have. I also have to add whatever they are telling me to my own knowledge base. So that is a high level of how a RAG chatbot works. Now let's talk about the tech stack that we'll be using. We make use of Langchain, OpenAI, Supabase, and a programming language of our choice. Langchain is an open source library for building conversational AI pipelines, and it has both Python and JavaScript libraries. So whether you're a Python developer or you're a JavaScript developer, you'll be able to use Langchain. So Langchain is the tool that we'll be using to manage the entire architecture, from the retrieval to the generation to saving the conversation history. Everything we are going to be doing with Langchain. We'll also be using the OpenAI API. So we'll be making use of ChatGPT model, and we'll be using their embedding model as well. And for database, remember we are going to be storing information. So for database, we are going to be using the Supabase vector store. Now, what is a vector store? It's a type of database that stores information in form of vectors. Now, vectors are arrays of numerical representations of text in this case. Finally, we are going to be using a programming language, of course, because we are going to be writing code. As it is in every machine learning project, you have to do something like data preprocessing. In this case, it is called data indexing. So we have the knowledge base document, which can also be called a context. Then we have to split it into different chunks. Have to do what is called vector embedding. Vectors are a way to represent the textual information that we have, and we're going to be representing it in numbers. So the process of converting the text to these vectors is called embedding. Now, these vectors are like arrays of numbers, and not just random numbers, but these numbers represent what each word means and also its relationship or its similarity with other words. So for instance, the word king and the word queen are kind of similar in the sense that they represent royalty, but they are also kind of similar in the sense that they represent humans. So there are so many ways that different words are similar to each other or are related to each other. This vector embedding manages the conversion of textual content into this vector space, and we'll be doing that with OpenAI embeddings. Then after that conversion, we are able to save it to a vector database, and the vector database we are going to be using in this case, like we already talked about, is Supabase. The entire process will be powered by Langchain. Now, under text splitting, we have something called chunk size and chunk overlap. Chunk size just means the number of characters that will be in each chunk of text. And chunk overlap means how many characters will spill in from one chunk into the next. So this is what an example of a vector store looks like. So you can see different questions. Do I need to be a member to use the gym? How do I become a member? What if I'm new to exercise? Do I need to bring my own workout clothes and towels, and so on and so forth? When we go back to the vector database, okay, so this second entry says, what if I'm new to exercise? We already saw that in the knowledge base. And there's the metadata column, which says from what line to what line can we find this information in the knowledge base. Then this is the main thing we're trying to focus on, which is the vectors. Now let's talk about the chatbot architecture. And this is what happens as the conversation is ongoing between the chatbot and the user. I think this is an interview question, by the way. So what happens is that this first time the user sends the question to the chatbot or asks the chatbot a question, we need to convert the question to something called a standalone question. And this is where prompt engineering comes to play. We'll get more into details about this when we start writing the code. So after generating the standalone question, the next step is to embed this question the same way we had vector embeddings for the knowledge base. We are going to be having vector embeddings for the user question, because these embeddings are what we'll be using to find a similarity or do a similarity search in the database to retrieve relevant information for the user. And that will be handled by OpenAI as well. After that, we go into the database and do a similarity search. We'll find the nearest match from what we have in the database and retrieve it. The next step is to do a generation, and this is where we generate a suitable answer for the user. So this standalone question here was only used to retrieve similar information from the database. We'll be using the user question directly to generate a response. So the user question plus the information we retrieve from the database, we will use that to generate a suitable response for the user. So this is exactly what happens the first time the user asks this question. Subsequently, we need to retain the information that we already have, the conversation that we already had with this user, things like what the username is, so that we can be able to have better conversation with them. So moving on, we have the conversation history here now, which is the memory. So after that first time the question is answered, the question will be saved in the memory. The answer will also be saved in the memory, and the answer will be served to the user. Okay. Now, second time the user asks this question, we'll repeat the same process, but this time around, we want to take note of the conversation history, just in case the user asks something that is related to what we've answered before or what they have answered before. That is why we need to add the conversation history this time around to generating the standalone question. So we still have the prompt preface, we have the user question, and we have the conversation history. With this, we are able to write a prompt that will send to OpenAI ChatGPT, large language model, and we are able to generate a standalone question. That question, we generate vector embeddings for it again, and we also go into the database to find the nearest matches. We move on to the next step where we generate a suitable response for this user. So we have the prompt prefix, we have the user question, the original user question, not the standalone question. We have the nearest match, which we got from the database. Then we have the conversation history. So we are maintaining the conversation history because we want to be able to answer the user question based on not just the knowledge base we have about this company, but also the knowledge we have about the user, for example, their name. So at the end of the conversation, we can just say, "Thank you, Jennifer, for stopping by. We hope to see you again." And guys, that is it for the RAG chatbot architecture. So like I said earlier, we could do this in Python or in JavaScript. So join me and let's delve right into the code.